Um, so I've been asked to introduce John, and let me give a little background with an introduction here. It's Dr. John. He's a graduate of University of Michigan, and I note that in his bio, he didn't put any dates in. So I wanted to point out that John and I were classmates together. Gives you kind of an idea what decade or what era we came from.
Yeah, I'll see more as I go.
So, John received his PhD at Stevens Institute. He's published widely, over 100 publications, and he's a licensed engineer, which is recommended for any practicing naval architects. So he's currently president and technical director of his own naval arc firm. He's an adjunct professor at the U.S. Merchant Marine Academy. Previously, he's been employed by Newport News, Rosenblatt and Son, and its successors, Webb Institute, and a boat builder. He's a member of SNAME, chairman of its Metropolitan New York section, or ASNY, and chairman of its Metropolitan section, and he's also a fellow at SNAME, where he is chair of the technical and research program. He's received the David Taylor Medal, which recognizes notable achievement. It's the highest award that SNAME's been able to give. So, John, it's a real pleasure to have you virtually back here in Ann Arbor, and I know that we're all interested to hear about your life experiences. So, with that, I'm turning it over to John.
Okay, Armin, thank you very much. I appreciate that introduction. And good afternoon, fellow Michiganders. I've been looking forward to have this chat with you on opportunities in the maritime industry from my experience, and I hope you derive some sort of benefit from this or interest. So when I was invited to speak, I thought about, well, what will I speak about? And I thought that, look, you're all soon going to be embarking on your careers. I'm sure you're considering what the opportunities are and what the features of each are. I will say one thing that I think, at least I wasn't aware of it so much when I was a student at Webb. There was some internship activity going on, but it was not as prevalent as it is today. And I think it's a wonderful thing for many reasons, but it certainly introduces you to different aspects of the industry, at least those that where you participate. And of course, you can talk to your classmates. And then you have, of course, as always, the university community, your professors, et cetera, and your professional society meetings where you get to speak to people in a profession. So there's a way to glean some knowledge about what to expect. But I've had as Professor Troche has mentioned, by the dates, it's a long career, and it's still continuing for me. I enjoy it so much, and I think you'll find that yourselves as well. And so I thought I'd add, since I have worked or come alongside a number of different segments of our industry, I thought I'd just review where I was and just my impressions of those. And I think you're going to find those same similar segments and core, whether they be design agents, ship owners, shipbuilders, but there's going to be change. There's always change in our industry. That's one of the main things I've found, and it always makes it an interesting place to be. So I'm gonna go through here. You can see down on the bottom the journey started in '69 when I graduated from Michigan, first time with undergraduate degree. But I'm going to talk a little bit how I entered the field. It's different for everybody. In fact, when I was teaching at Webb, I would go around the class. I was teaching, one of my classes was with freshmen, and I go around and have everybody say a few words about how they first got interested. And it's all over the place. Sometimes it was a lot of Marine background. Other times there was very little Marine background that brought people there. But there are beginnings for everyone. I first started out in the working part at a shipyard. This is after graduating. I'll say some other Marine things, but then graduate school, working as a design agent, research from both aspects of design agent, and then even as a professor. working in the offshore industry. Actually, that was through being a design agent. Boat building, I had my own boat building company at one time. And then impressions working for a ship owner. I was never worked directly for one, but as you can appreciate, if you're a design agent or in a shipyard, you rub elbows with them all the time because they're your customers or one of your customers. Working on Wall Street, that's a newer thing. And impressions working for the government, again, as a design agent, at least in the area that I was in, I had a lot of involvement with that. With the classification societies, impressions there, right, on commercial ships and now naval ships, you use those rules as you go through your design. Then I'm going to talk about professional engineering registration. As Professor Trosch mentioned, it's important, and I'll double down on that. And then the importance of professional societies and touch on starting your own business. So I grew up in New York. It's where I live now, out east of New York City, out in Suffolk County, in waterfront type of community. My family didn't own a boat, but we would, although we surf cast from the shore, did that type of fishing a lot. Every once in a while, we go out and rent a boat, and I just loved being on that boat and out on the water. Although I was on the water from the shore, it was a whole different experience, and I was hooked. I built my first vessel at 10, and I mean, this was no hydrodynamic miracle. It was a couple of 55-gallon steel 55-gallon drums with a wood frame around them. I bought my first boat at 13 and started commercial fishing. You can see there in that picture, it's my buddies in my Jeep, and we're about to go down to our boats to go out clamming. That was our commercial fishing. We tried to bring a little more sophistication to it, and we call ourselves bivalve extractors. At 17, I designed and built my first boat. After graduating, I studied engineering at Rensselaer Polytechnic in New York for a couple of years before I knew I had to get to the marine area. And I transferred to Michigan in my junior year and entered the marine engineering option. I don't think you have that now, but then there was a naval architecture, marine engineering. It was smaller marine engineering, but it aligned with the general engineering I had at Rensselaer, and it would let me then graduate in line with what I might expect in '69, and that's when I did. So the first thing I did is I went to work for a shipyard, and as I said, I didn't do anything on the interning. Maybe there was opportunity there, but I was always trying to get back to my clamming, which I did right through college. But as I recall now, I think there were only 2 companies that interviewed at U of M, and one was Ingalls Shipbuilding. They were building up their shipyard from scratch. They had a design office in California, and the yard was being built in Pascagoula. For the DD 963 program, a huge program that Lytton had won, and Newport News Shipbuilding. And I went with Newport News Shipbuilding, and I had a wonderful experience there. I was only there about a year and a half because I went back to Michigan for grad school, which I'll mention in a little bit more about. But I got to work on all the ships that you see here. I went there again. I was not a naval architect in that regard, although I had the naval architecture, the certain courses there and so forth. But I went in as a marine engineer, and I went into that department in the main machinery section. So we had all the propulsion machinery, as an example, to deal with. And the Nimitz aircraft carrier, which was has been the design of record for the United States until just recently with the new Ford class, although there have been changes along the way. In fact, even worked on some of those as a design agent. It was in detailed design. It was being constructed, the first vessel, the Nimitz itself. But there was a lot of work to be done. A lot of it was in shock analysis of the propulsion machinery, and I got to work on that. I was the only actually graduate marine engineer in the department, and they were a little short of personnel in that department. I was the only new one. And in fact, Roy Harrington, who you may recognize as the editor of the book Marine Engineering, was actually my supervisor, although he was in charge of one of the 2 people in charge of the whole marine engineering section at one time because they were shortage on personnel. So I had great mentors as well, and other mentors there. And then the DLG-N36 nuclear-powered cruisers, the first couple had been built. The DLG-N38 was still under construction. There was some alterations going on I got to be part of. The SSN-688 attack submarines, which till about 10 years ago were the country's staple as far as attack submarines, they were also in detailed design, and I got to work on the propulsion machinery related to those. Then the next items, Newport News was a very significant commercial shipbuilder at that time still. And we had one project I have there, the Exxon icebreaking tanker. There was a project to design these, which would have been the largest oil tankers in the world at the time at 310,000 deadweight tons. But more uniquely, they were triple screw with 100,000 horsepower on each shaft, and their purpose was to bring oil from the newly found oil on the north slope of Alaska through the Northwest Passage ice down to the East Coast refineries. And at the time the design was going on, and again, I was working on the propulsion machinery design, actually did a fairly detailed design of the propellers, 36 feet in diameter for an ice-breaking vessel. They had that ship in the lower right-hand corner I have on my screen. It was the Manhattan. It was a 110,000 deadweight tanker, put a ice-breaking bow on it. And while the design was going on, they sent it up through the Northwest Passage to see how it would do. And it got stuck in multi-year ice. And when that happened, although Exxon was going to make this big fleet of these large ice-breaking tankers, they canceled the whole project because they had to be certain of a 24/7 operating situation. You could imagine if that went on now with the receding Arctic ice, this would probably have been a done deal. But what happened back then, this was stopped, and they made use of what was then built after that, the pipeline, which would bring that oil down to Prudhoe Bay and offload it on ships like the Exxon Valdez, which of course is a ship that had problems, but nevertheless, that's the way that all went. And the largest ships ever built in the United States, the 440,000 deadweight ton tankers for Shell. I never worked on those, but Newport News was trying to sell those ships as well as the LNG tankers, which they later built. And they had customers coming in all the time, and we had a redesign for different principal characteristics, et cetera. And I was probably doing 2 resistance and propulsion. They let me do that. Normally, maybe that would have been in the naval architecture section, but for whatever reason, I was doing about 2 a week on different ships. I don't think I ever did as many in the time I was at Newport News shipbuilding that I ever did in the rest of my career as far as that goes. But it was a wonderful experience, and my impressions of shipbuilding from that are it provides direct exposure to construction, work with individuals who must create a product from paper to digitization, daily feedback on engineering from production, and you get to go down to the shops and see it through, frequent troubleshooting with stopping production at stake, great pride touching your final product in sea trials. You're part of a large company with upward mobility and reward. But after that year and a half, I was actually encouraged by the shipyard, and I myself wanted to go back to graduate school. There were questions that came up, and I said, I got to find out more about that. Like FEA, it was known at that time, but very little use at that time of FEA. I went back to Michigan, and I tried to work through as quickly as possible so I could get back to work. So I was there 71, 72. I did it in 2 semesters. And when I left, I felt I had a command, or at least the background knowledge of theories in hydromechanics and FEA, where I could do it or go out and find out how to do it on my own. It proved to be a great foundation and gave me an edge after I re-entered the industry. And how I did that was I didn't go back to the shipyard. And my main driver was I wanted to come home. So I came back to New York, and there were more limited opportunities. New York still had quite a bit going on in the marine industry, but it had started its downward trend. But I was fortunate that there were still some significant naval architecture companies, and M. Rosenblatt and Son was headquartered in New York City. It had as many as 800 employees when time I was there in its various offices, but New York was around 200 or so. And I remained there with Rosenblatt through 2000. So I was there quite a while, as you can see. And then they were acquired by SAIC and went through some various other ownerships, including Northrop Grumman and Huntington Ingalls. And I was with that throughout the whole thing. And it's interesting, I wound up, big great circle, right? Huntington Ingalls was formed with Newport News Shipbuilding and Ingalls together as a spinoff from Northrop Grumman. And I was part of that. I started at Newport News and I wound up in the same organization, so to speak. And I ultimately rose to senior VP responsible for all engineering at Rosenblatt. So I got to see quite a bit. Wide-ranging opportunities from research, design, supporting shipyards, supporting ship owners, private industry, the government. We did it all, mostly on large ships, not on small boats. And my graduate education supported me convincing others in the design area to engage in applied research and also apply technologies which they might otherwise be reluctant in applying. So, I was very fortunate. All the ships you see here, I either worked on the design of or led the design of, but we had designs in new building, conversion, modification, rehabilitation. I worked on oceanographic ships, mobile offshore drilling units, combatants, naval auxiliaries, container ship tankers, bulkers, sailing vessels, motorboats, icebreakers, buoy tenders, museum ships, even a cruise ship. Now, you know, over 40 years, you could see all these, but we had a lot of action. And again, I consider myself part of, and there were a few others of moving us to also get involved in applied research. Research was always directly to come up with some solution. But you can see here the breadth of activity from shipbuilding, design, synthesis, structure, even aids to navigation, collisions, hull forms, vibrations, and so on and so forth, underway replenishment. And the bottom line, a wide range of satisfying activities with always something new on the horizon. I think that's true of all naval architectural, design agents. So on the research side, I put research here, but you know, I continued on with research and also in the time I've been a professor. But I already mentioned all these various areas, and that I've focused on the applied. And again, not being specifically a researcher, I've come up with this number of publications, which I've just enjoyed. Some of it's just been from my own interest, you know, and looking at something, hey, you know, that'd be something to look a little further into, and then going with it and participating with it in professional societies. And on top of it all, it's good for the business and you personally, because people notice, you know, you're doing this, you know, you gain notoriety. You have an opinion on something, and you're going to have people that might pick up on that and will likely pick up on it. But it also fosters new ideas and approaches, and you get customers that way too, if they note that that's something that you're involved in and showing the potential for some solutions. And of course, I'm talking about it here from my experiences mainly in a design agent, but clearly it's at the center of activities in academia, laboratories, and it's both government and industry-wide. So a little bit more on graduate school, because I also pursued a PhD while in industry. I started with that at Stevens in 1974 at night. And I would go there after work in New York City after, you know, I lived out on Long Island, so I had to go west to get to New York City. And then I had to go west across one river and then west across another river to get to Hoboken in New Jersey. And then back home late at night, 60 miles to do that. And they were, from what I gather now, little owners on the requirements. They wanted 30 credits above a master's of coursework before you could take a qualifying exam and then move on with your thesis work. But I graduated in '83. You can see at 34, you can see it's 9 years it took me to do that. And I remember thinking then, you know, I did this, but I'm really too old to, at this point, you know, to bother with that, although it gave satisfaction. But it turned out to be one of the best things I ever did. It's opened really a lot of doors. So working in the offshore industry, now I never actually worked for a offshore related company, although I did work in their offices because they had sometimes hot projects and we would like co-locate. But I had quite a few experiences. Actually, I got one, two, two of the vessels here. I worked on all on the design on, and two of them I've got replicas of vessels that I worked on design, but I quite a few because we did do quite a bit of work with this was through Rosenblatt for the offshore industry, and they were oil related vessels, but also developmental work. I note here ocean thermal energy conversion, OTEC. I don't know if that's even discussed today, but it was in the solar area and it was involved with taking heat out of warm surface areas and tropical waters and then through a thermodynamic cycle extracting energy from it to run turbines and then generate electrical power. And that was at a time, that was in the 70s when there was great desire to veer away from oil because we didn't think we had much oil left. But you know, it's kind of similar to what we have now that we want to do that. But once it was determined that there was a lot of oil around and the price came down, everybody forgot about moving away from oil is our way to for source for power. But it looks different now, and now we have wind, wave, and tidal opportunities, and they are also, the offshore industry itself is focused on those. So I would still categorize that as the offshore industry. If you see some of the ships that are being built, they're being built by companies that to service these things, et cetera, that are historically in the offshore in terms of oil industry. And a lot of that has to do with that they're getting into that too, is the next bullet here, where when there are big problems to solve, the money flows in this industry. It's exciting. It flows so much. In other cases, you know, everyone's trying to bring the price down. Money's hard to get, whatever. When there are things to do in the offshore industry, my experience has been, you know, money is not an object. And it really gives an exciting environment. The one problem with it is when the price of oil goes down, so does the industry. And you can see that right now. And it was very high a while ago and it's down, way down right now. So most in this industry are not naval architects and marine engineers, so there's great need and opportunity. It was the case when I first started working on this back, it was in the 70s and continued for decades after that, but started then, and it still is so now. So there's great need for people that understand that part of the engineering. There are many large companies with upward mobility. Boat building, okay? So my interest in boats led me into the field, and I had built some small boats when I was younger. So when I went back to New York, started working for Rosenblatt, I started a small boat building company with my high school fishing friend. And you can tell this was a hands-on operation. That's the two of us up on the left-hand side there. But I was the full-time NA and helped in the building. Our construction process, you can see there by the other top photo, was hardwood frames, fiberglass covered plywood. We built a couple of hundred of different types of boats, mostly for fishing in the community that we had been part of when we were a little bit younger. And then when my partner lost interest, we sold the company. But like shipbuilding, it brought great pride in seeing the product delivered, and your boat owners revere you. They just think that no one knows anything more than you. It's a terrific feeling. Impressions working for a ship owner. Okay. I didn't actually work for one, as I mentioned, but you know, obviously they were customers. So it can be in blue or brown water, salvage industry, or now the wind farm industry, and all the new alternative energy water-based activities, satisfaction of seeing your ships throughout their lives. Customers, the customer, your customer now is not necessarily a marine entity like a shipyard, it's a ship owner. Here it's going to probably be a shipper. more management than application of engineering and science. In the end, it turns to that. Of course, these are all my opinions by observation. Knowledge of and interest in economics is very important. Companies and positions within companies less stable than other areas. That's what I've seen, even though some of the companies are large, if there are ups and downs, that results. And again, more focused on company economic performance than naval architecture, but there are many large companies with upward mobility. Working for Wall Street, this is something, I'm sure it's always been there, but from the Marine side, it's more recent, I feel. Shipping companies have historically been more privately held organization and specifically even specific families. Now, many are public companies traded on the stock exchanges. And at the same time, there are investment companies that have been created that they themselves create funds, like a Fortune 500 fund, but this one's based on ships, which invest in the shipping sector. I've got one noted, Northern Shipping Funds, on the bottom. I had a student at Webb in the recent times that went to work for them. And this migration has created opportunities for naval architects who can help investors assess viability. Impressions working for the government. Again, this was through activities with as a design agent. It's a mirror, I think it's a mirror image of the same opportunities as in private industry. You've got design, engineering, research, ship owner, even shipbuilder. Nevertheless, there's a greater preponderance of those involved are more in the management realm. You have to be very knowledgeable about all the technical aspects because you go out and hire companies. There are those that feel, for instance, in the naval area, that the Navy's gotten too far away from that it should go back and have more of that work actually done within its own organization. It would be better off. And who knows, it could change that way. As I mentioned, our industry, at least the way I see it, changes all the time. And it's usually stable employment for life in the government. There's no opportunity for the high end of private compensation, private company compensation, like stocks and things of that nature. I'm going to say a few more words about that. And I put in parentheses here until you retire, because then you're free to go work where you want. And in fact, there may be greater opportunities for you in the private sector because of your government experience. But nevertheless, there is a pension. Notice I'm throwing in a few of those things. I'm assuming you, if you're not, I know when you start out and things, sometimes you don't worry about all those things to the end of your career, whatever, but it's good to think about that since there's a lot more information about that now. Working for a classification society, again, this is not something I did, although I considered it, but it would have had me move away from New York, which by now you can tell I just don't want to do. They don't design ships, but everyone uses their rules to design ships. They're not intended actually for the design of ship. They're intended to give some criteria of what your design should look like, right? But that's not totally the way it works in reality. Their primary goal is safety, and there is more consciousness about that now than ever, no question about that. You can see their focus over the years moving more in that direction. There are opportunities there in design and engineering, research and shipbuilding inspection, and ship operations oversight. I mentioned the design and engineering as well because it's happened that classification societies also have ancillary companies that provide this service to others, similar to what a design agent would do. And you're involved in every major sector of ship and offshore, the offshore business, if you're with one of those. And more recently in naval, the Navy used to have its own rules. They were called the general specifications in the United States for the design and construction of naval ships. They were abandoned decades ago, and there's been a lack of documentation for that, at least over some period, and then it was picked up by the classification societies. There have been a few permutations on that. But downturns in the oil affect this sector. Now, you would think they're involved with all these other things, but it can only be that there's so much of their business is with the oil sector that when the oil sector goes down, the classification societies suffer greatly, and it causes some instability at those points. So being a professor, I mentioned I'm an adjunct at the USMMA, and I have been an adjunct at Stevens, but I was for 4 years a full-time professor at Webb Institute. I can say that second bullet, it's the hardest thing I've ever done. And today's students have a lot of say in the process. You should be very good to your professors. It's a very tough job. But there's great satisfaction in doing it than seeing your students as peers later on. I know that although it's not impossible, it's more difficult to find an opportunity to do this without a PhD. And certainly in a major university, you can't do it without a PhD. You find out early from a standpoint of a career. I think you'll find out early if you're suited for it. And if you are, my impression is it's stable employment. And besides teaching, it represents a wonderful opportunity for research supported by bright and eager young minds. Even though Webb is an undergraduate school, I was able to do a number of research projects with those undergraduates, and I had a great time with that. Professional engineering registration, as Professor Troche mentioned. I sought to obtain this as soon as possible as I could, and I did. In 1974, I got my New York PE. I was given a credit for my master's, and I was able to lob a year off the number of years you needed to work in the profession to actually get to the license. In 1990, SNAME sought to develop an examination to be given nationally on naval architecture and marine engineering, and now it is administered by those that handle these exams, and it's available. I'm not sure. Last I knew was in 48 states. It may be all states at this point, but now, but one thing is, although you can take that exam, most states don't define the expertise. They don't say on your license whether you're a naval architect, a marine engineer, mechanical engineer, civil engineer, etc. But it's up to you to practice in an area that you're competent. And of course, where you would be called out on the carpet on that is if you ever did something that wound up in the courts, you would have to defend your situation. But so in reality, you could take an exam in structural engineering and you could still practice as a naval architect. As the years have gone by, the naval architecture profession has become more scrutinized as requiring a PE. In the beginning, it was great. People were up in arms about this, particularly, for instance, in Florida, where there were a lot of boat designers that didn't even have the undergraduate education that some states require that you have before you can apply, you can take the exam. Meanwhile, they were legitimately in the work they were doing, many experts, and Florida relaxed their requirements in naval architecture and marine engineering. But in general, that's not the case elsewhere. As far as I know, anywhere else you would be required to be a PE. And if it was on big ships, I'm sure it would be it's the case even in Florida. I had a Florida license as well for things that I did. But anyway, if your career is going to take you where you work for a company selling engineering services, you're selling a design, that's selling services to the public. It's considered you will be likely require. I say likely. I don't think there's any state that wouldn't require you to have a PE. At least for the person in responsible charge, but chances are the company would even want you if you were doing enough of the work, even if you were working under someone, or try to work towards your PE. If you work for the government or a company that sells a product like a Shipyard, or for instance, Ford, if you're an engineer at Ford, you don't need a PE because the product is the automobile or the ship, and that goes under product liability. You're not selling a design to the public, but nevertheless, they may acknowledge and reward you. My experience has been that they do acknowledge and reward you if you do have a PE. I wound up having 19 licenses. Now I didn't have to take an exam for each one of these. Once you have one, that facilitates the whole thing. And there's a way that you can make this more easy. Now I want to say something about professional societies. In our field, the prevalent ones are the Society of Naval Architects and Marine Engineers, SNAME, the American Society of Naval Engineers, ASNE. There's a number of people belong to the Royal Institution of Naval Architects in the UK, RENA. A number belong to the Institute of Marine Engineers and Science and Technology, IMRS, in the UK. And actually here in New York, we have an eastern branch of that organization. And then the American Society of Mechanical Engineers, and then the Connecticut Maritime Association, which is more tuned to ship owners and operators. When I entered the industry, it was almost essential that you be a member of SNAME. The leadership of companies and organizations promoted it, right? One of the biggest reasons or most significant reason is if your boss wants you to join, you know, chances are it's a good idea. So, but it wasn't just that. They made it fun. They made, you know, they encouraged you to be involved. I mean, I worked for Lester Rosenblatt, and then later Bruce Rosenblatt. And I don't know if there's anyone in the industry that promoted SNAME, has over the years promoted SNAME more than them. And it really was something to see. And, you know, their customers loved it. They would invite their customers to functions and so forth. It was also a professional, it was a professional and a social situation. As it is and can be now, but it gave you great contacts, opportunity to learn through papers, attending meetings, participating in society organizations, and delivering your own publications. The opportunities in societies have and continue to be indispensable. This is my opinion, obviously. Yet at the same time, they're struggling. All societies have a significant reduction in membership. SNAME, I can remember when SNAME had 13,000 members. It's got about 5,000 now. So there are these significant membership and reductions. Everybody is struggling to say why. Is it the leadership, less interest by leadership of companies? Is it because we have the internet now, we have social media, and everybody's trying to figure out what's part of all this. But I wouldn't dwell too much on that. I think you should try to stay with these societies and get involved. And I think that will sell it to you on its own. If you're in a few years and it just nothing is happening, then you can decide on that. But I think it's a mistake not to get involved and stay involved. Use it, you know, societies find students get involved as student members, then they leave. But you get out of them more than you contribute. And I'll just say, if you contribute, it'll make it that much better for the society and for you, and it'll keep you there as well. I just note this, it's hard to read here, but you can go on, this is the TNR program in SNAME. It's unique of any professional society. There's none that I'm aware of that has something like this. You can go on the SNAME website and the technical and bring down the org chart and take a look at it in detail, but it has committees. There's hundreds of people that are involved in this. It has committees along the top. There are hydrodynamics, hull, ship's machinery, operations, offshore, environmental engineering, ship systems, marine forensics, small craft, and ship production. And then all the panels are subsets of those, and they all have chairs and members. And they're people of common interests that get together and talk about important things in the business currently, or in marine forensics in the past sometimes, but also how to go about investigating things in the past. But and they may even develop industry standard guidelines, as SNAME bulletins, guidelines, and reports that have over the years affected the direction and some of the decisions by regulatory organizations around the world. And if you get involved in these, you have a specific interest in any of these areas, you'll be meeting with people that are right at the forefront of that technology, and you'll be able to be part of it, learn from there, contribute, and it'll make a involvement in the professional society that much more rewarding and beneficial. Starting your own business. If I got it, I'm getting towards just about the end here, so maybe I'll just go through. I don't know if I went too long on this. I actually never asked how much time I had, but starting your own business, it's wonderful. Excuse me, someone, no. It's wonderful and rewarding opportunity if you can do it. My first in the industry was boat building. I've already mentioned it. The second in the industry came in a roundabout way, but it was due to professional engineering law in New York. And this law exists elsewhere in the country as well. In New York, a company offering services of a licensed profession, of which professional engineering is, it could be medical doctors, dentists, things of that nature as well, such as engineering, must be owned by the profession. The company needs to be owned by the profession. Actually, until just a couple of years ago, to be 100% owned by the profession. Now they give a little bit of relaxation on that, but so it means, but essentially it means that only professional engineers can own the company. And my company, AENY, was established in 2006 as a consequence of this, because I had a relation with another organization where work in New York really couldn't be done by that organization because they didn't fulfill that requirement, and we handled it through my having this company that in fact was owned by a professional engineer. So starting your own business is wonderful and rewarding opportunity if you can do it. But another similar opportunity exists if you can get in on the ground floor of someone else's startup with some, or even it doesn't even have to be a startup. It can be just, you know, a little bit ways into it, or a company that's going to have a lot of growth with some path to ownership, stock reward, awards, options. You don't see so much in options today, or some employee stock ownership plan. And this same sort of benefit can also happen if you're lucky enough to be in a company that is bought out and similar incentives are offered. I actually had both of these happen for me when Rosenblatt sold, and then we went through this. It was acquired by SAIC, and then went through some other ownerships. So today, more than ever, I think it's worth, especially with all the activity in the stock market and all the interest, it's more than ever worth exploring these aspects, as they do exist. And there are a lot of companies changing hands along the way. So changes in the workplace. Today, many are working from home to avoid spread of the disease. I mean, you're looking on right now in the same situation, right? Hard to do. It's hard to do in a shipyard, factory, facility where confidential work is accomplished, or university. So those have been challenges in those places. In the services sector, it's much more possible. For instance, in my own company, we have a headquarters office in New York City, and most of our work is focused in the New York area by design. But in any event, we do have employees in 5 states, and we rarely have to meet, so we're able to work from elsewhere. And I just note here, it's a far cry from my commuting every day on the Long Island Railroad, 40 miles one way. So, and also I just note, you know, other things that we were talking about this earlier. I'm an adjunct for the USMMA in their master's program in marine engineering. This has been done over the internet, actually since 2008 when it started. And it's been a wonderful, you know, apart from now, you know, we got to do these things, but for the people taking this, a number of them have been engineers at sea. So I know in my classes, I've had people all over the world tuning in for, you know, our get-togethers, and they've been able to get a master's degree under those terms. So areas of rapid future change, like I said, it's change everywhere. You got hybrid, electrical, fuel cell propulsion, digital twin, artificial intelligence, machine learning, autonomous marine vehicles and swarms, ocean energy. And so we got wind, wave, tidal, maybe, who knows, OTEC will come back. We're all going to be dealing with the greenhouse gas situation and the required reductions in that are going to move very quickly along. Some of them seem like maybe they're further away, but the time moves by very quickly. Aquaculture, fish farming, additive manufacturing, 3D printing, there are others, and it'll just continue, I think. So all I can say at the end is you've got a wonderful trip ahead. I'm still enjoying it. I'd be willing to start all over again. It's been so much fun. So I'll leave it at that. If you got any questions and comments, thanks for listening to me.
John, that was really interesting, and I know that the students and the faculty enjoy hearing these stories about people who've gone out and been very successful. It's quite an impressive career. That sounds like it's still going very well.
Thank you. Yeah.
So I don't know, at this time, I'm sure what we've done in the past, if we said, are there students or comments from the students or questions from the students? I know that John would be happy to talk to you for a little bit. Anything from our students? These are always awkward silences where we can't browbeat the students.
That's okay.
Questions.
I'll take it that I threw out a lot of things they're thinking about right now, but
yes.
But I'll just continue to say you got as I see it, you've got more opportunity. You have got more opportunities, and of course, even outside of the Marine. I mean, I've obviously spoken about the maritime industry, but having a Michigan education in naval architecture and marine engineering, there are a lot of other things you can do as well. And of course, we've got so many opportunities in this world today. But the Marine, Lester Rosenblatt used to always say that the one thing we've got, the biggest thing we've got on our side as naval architects and marine engineers is the world is covered by 75% of it's covered by water. So there's always going to be plenty to be done associated with that.
Yeah, and one of the pitches that we've made in the past is Secretary of State, former Secretary of State Don Winter was on our staff as a professor of practice. He just assumed emeritus position, and we would have conversations about how naval architects are essentially systems engineers. And that concept of our education as systems engineering is really transferable to almost a wide number of industries and practices. For example, our students do extremely well in med school and law school. And I think it's the background of looking at a ship, which can be really complex, and understanding how things fit together has served him extremely well.
Yeah.
So
I agree with that.
It's an exciting field.
Yeah.
Hey, John, if I can ask a question, there's no question from student. You mentioned that when you were here, you're the only marine engineering student, the rest were naval architect.
Yes, it was a split program. There were only 3 of us in the marine engineering side. So it was small, and I guess it was dropped. I don't know if Armin, you can remember more about that, but and I don't know when that happened, but yes, it was just the marine engineering part.
Yeah, so
it was, Jing, it was interesting back then. You could choose to take a thrust area in naval architecture or marine engineering. Everybody got the same degree. Or when Francis Ogilvie got here, you could also take it, and I don't know if I'd call it marine science, but it was more of a analytics based direction that you could take. So there were basically 3 paths that you could focus on. Everybody had to take a 470 or 475 design class, but you could focus in one of those 3 areas.
yeah, so I'm just wondering, when you, I mean, how the mindset would be different at that time, and now, you know, now we see all this Navy as just one society, right? At both aspects of naval architecture, marine engineering. But I was wondering if the marine engineering is like a second thought for people come into this field, or because I'm in the marine engineering space, but coming from a different background, from electrical engineering background. So I'm just interested to see how this, you know, the field has been transformed, and how what do you see the big part of the marine engineering? Because I think that you know, in terms of diversity, topic diversity, we have a lot of different things in marine engineering, but naval architecture seems to have a strong focus on the ship design. So how does that?
If I may just say something about that, one thing about marine engineering is that if you look at the whole student population in the United States, all the academies, which if you add up there's one federal, the U.S. Merchant Marine Academy, but then you have, you know, New York has an academy for training individuals for operating ships, Massachusetts, Maine, California, and so on. There are a number of them. If you add up all the students that are attending those schools, it dwarfs, you know, by very significant amount, orders of magnitude probably, the number of students that we have in schools, in universities that are studying naval architecture and marine engineering. Now, a lot of those students are training as deck officers, so they're really apart from any engineering activity. If we broadly define engineering, is not broadly define it, but they're not really learning or studying in engineering per se. But there is a whole other group in those schools that is taking on the engineering aspects from the standpoint of being in the ship's machinery spaces and being responsible for those machinery spaces. So when you go to those schools, if you look at their engineering departments, they're mainly focused on marine engineering in the terms of machinery, because those people on graduation, their number one goal is to obtain a U.S. Coast Guard license to actually operate that machinery space. So they're learning how to do that, and along the way, they're taking what would be a very formal and I think significant engineering course, but they're really not getting into naval architecture much. And if there are a few that maybe get into the naval architectural aspect, but I think when you go out in the industry, you'll see that a lot of the need probably on the marine engineering side, or at least some of the need on the marine engineering side, is being satisfied by the people coming out of those academies.
Thank you, John.